It's fine. All right, so we're going to use this pink paper in transparency shabops to help us visualize what's actually happening with the electrons. So we're saying metals are donating, electrons are accepting. Okay, so we're going to look at a first example here. We're going to look at sodium and chlorine. Okay, we're only going to draw Lewis dot diagrams. What do I draw when I'm drawing Lewis dot diagrams? Dots. And what do the dots represent?
Valence electrons.
Valence electrons. Okay, so if I look at sodium in my periodic table of love, how many does it have? 1. Okay. If I look at chlorine, it's in group 7A, so it has 7. No, you all don't have to draw yet. Okay. So, here we go. We now have represented sodium and chlorine, with beans being our valence electrons. Okay? We just said that metals donate. So what do you think sodium's going to do with this 1 electron?
Donate it.
Where do you think it's going to go? To the chlorine. Okay, so I want us to think about this. Metals donate the electrons, non-metals accept them. Okay, I want us to remember that underneath this layer is another shell that has 8 electrons. Okay, I'm not drawing out the whole thing. Let's think really quickly about our protons and electrons. Okay, so if I look at sodium, how many protons does it have? Take a look at your best friend. 11. Oh, you're not drawing yet, so just give me a second. Okay, 11 protons. So that means it also has 11 electrons, which gives us a charge of 0. Okay. If I look at chlorine, so I don't have everyone, I'm waiting. I'm still waiting. So, if I look at chlorine, how many protons does it have? 17. And it has 17 electrons for a charge of 0. Okay? So, sodium and chlorine come to see each other. They're in the same vicinity. Remember that electrons want to have 8 electrons in their valence shell. What did we call that rule yesterday? The octet rule. Fabulous. Okay? So, sodium donates this 1 electron to chlorine. How many does chlorine now have? 8 in its valence shell. How many does sodium have in its shell now? 0 in this valence shell, but now we've moved down to the next shell, and it has 8. So they're both reaching that octet rule. But we need to look at the charge now. Have we altered the number of protons in either sodium or chlorine? No. All we did was change the electrons. So I still have 11 protons here. I still have 17 here. Okay? For the electrons, how many did I move from sodium to chlorine?
1.
1. So sodium has how many less? 1. Okay, so that's going to give me a charge of +1. Chlorine, please. Chlorine has gained 1 more, so now it has 18, which is giving me a charge of -1. Okay, so y'all are going to act out some examples of this. Before we do that, though, I would like you to draw this example in your notebook. So, I have Na, I have Cl. I have 1 valence electron, and then I have 7 valence electrons. So this is before the bond, right? Before the bond, like we just said, the charge is 0. So Na is going to take this 1 electron and donate it here. So now after we should all be copying this in our notebook. Cl is now going to have 8. Okay? Our charge here has become sorry, I should write it down here. Plus 1, and our charge here has become negative 1. So I have Na plus 1, Cl minus 1. What do we know about positives and negatives? Do they attract or repel? They attract. So that's what's causing this bond right here. The positiveness of Na is attracted to the negativeness of Cl. Opposites attract. Does anyone remember what NaCl is? Table salt, sodium chloride, okay? So this interaction is happening in our foods, okay? That the NaL is attracted to the Cl. Do we have questions about this one?
What happened to Na?
I'm sorry?
What happened to sodium after?
So sodium, if you remember when we were looking at this example, right? It had one valence electron, right? And then it has a shell inside of that, right? That had 8. So when it gives this one, now this shell is no longer the outer shell. The one below it is that has the 8 electrons. And now this chlorine's outer shell also has 8 electrons. So they both met the octet rule. We've got the structure that we need for atoms to stop reacting. Does that make sense? So now I want you to try magnesium and oxygen. So you're going to act them out using your pink sheets and your markers. And I have beans and such for somebody. This table? Okay.
Magnesium and
Can we say it right? So we're trying magnesium and oxygen. You're writing in Mg and O. You're putting your beans down. Oxygen, it's up there on the board.
Can you pass me some of those balls? Can you pass me some of those things? I need to take them.
can you explain why the charge? Why the charge? I want to know how you
It's a different question. Before
No, you didn't. You just not.
That's good.
Yeah, it's supposed to be like
So these two electrons should be there's still 12.
Now I have.
Okay, 100. How many? 10? How many electrons?
So I want you to go to the
So for
Hold on. So, how many electrons? Okay, how many valence electrons does that look Forget, were you both times?
the bills electrons
So, metals donate their electrons to the non-metals. So then we start out with all zero charge, that's just like the way so the metals donate, so magnesium is a metal, so it donates. So what you would think about something is it going to be easier to take 6 or donate 2? Donate 2. So we're going to donate 2 over here. But I want you to remember that magnesium is still transferred right? We only do 1. Yes, there's 2. Because this was just the paper that makes Okay, so now it only has 10 electrons, right? Okay, how many electrons does oxygen have? So it has, yes, 10, perfect, right? What about protons? Does the protons change? No, so how many protons do you have? So, 12 times the positive 1 is, yeah, not add. That's fine. 10 times the negative 1 is negative 10. So what's the other one?
and then
Okay, so what am I going to do here?
Like that?
Yep. So my overall charge is yeah.
how do I finish this last part?
Okay. So what we've done is we've gotten to a point where magnesium has 8 valence electrons because the shell's gone, right? And oxygen has 8, so we met that on target. Yesterday was just as long as the atoms have valence electrons, they're done. They no longer interact with other elements. They're chilled. Okay. So now this magnesium and oxygen are happy sitting out together because they've reached the number of electrons. Okay, so we'll try another example in just a minute. Thank you.
No. This is charged. How many electrons does it have after? And with 8? Yeah. So
Here are tables.
added 2 electrons to it. So what would the charge be?